Przechodzimy do następnej prezentacji.
We move to the next presentation, which will be also delivered by a speaker from Spain, from IDOM, Fidel Sesumaga Gonzalez, who represents a consulting engineering company, and the title of his presentation is Implementation and Development of the Local Supply Chain Facing a FOAC Reactor, first-of-a-kind reactor, Challenges in a Nuclear Power Plant Construction for Newcomers. Fidel, the floor is yours.
Yes, hello. Can you hear me?
Yes, we hear you, and we see your presentation as well.
All right. Thank you very much. I guess I can get started. Then thank you very much for the introduction. And indeed, IDOM based in Spain. Myself, I am based in Brussels. IDOM being quite yes. Oh, okay. So I thought you would not see that one. That's fine. So I will put it this way. Is that better? Okay. Very well. All right. So as I was saying, so first of all, let me do a quick presentation of IDOM, and then we will get to the core of the subject. IDOM in the world, as mentioned, IDOM is an engineering, consulting, and architecture firm. It has been delivering independent professional services since 1957. Very international presence with offices in a wide number of countries, around 3,800 people. It is an employee-owned company. That's the number of partners that you see on that slide. Quite a few areas of business. I will highlight some of them that are interesting for the presentation. Obviously, very, very specialized in energy, architecture, and in particular in nuclear, which has a nuclear department, as I will show on the next slide, just after this one. IDOM has expertise in managing a wide variety of projects where engineering is involved, but also in EPC projects, as you can see, in cogeneration plants, PNC, as you can see, for the refinery of Talara in Peru, also more from the pure engineering perspective with the Metro of Riyadh, or the whole management of architecture EPCM contracts as a football stadium of San Mamés in Spain. In terms of nuclear services, IDOM has around 40 years of experience and has delivered more than 350 projects in 23 countries, as you can see on the image attached, and around 400 experts specialized in this area. IDOM works with all stakeholders at the nuclear supply chain level, both with governments, public organizations, and agencies, so supporting in technology choice, policies, and strategy. Also with nuclear owners and operators, delivering projects directly at the utilities, and also with other actors on the nuclear supply chain, whether suppliers or partners delivering projects across the world. In terms of value proposition, it is an independent multinational company providing services worldwide, locally as well. IDOM has offices as well in Poland, and any services in the country would surely count with that local presence. The advantage also is that multidisciplinary, tailor-made teams, with elements both, from, the architecture, other industries as well, nuclear expertise, with also the consulting flavor that characterizes the company. Obviously, working in nuclear, there is the nuclear quality and safety culture that we will be viewing in this presentation. Now, after that brief introduction of the company, the core of the presentation today, indeed, it's focused on localization and first-of-a-kind reactors and some of the challenges for the local supply bases, but also we want to touch a bit on the localization strategy aspect of it that has the advantage of viewing the perspective of the government utility, but also the local vendors that need to participate into this strategy. If we get started into looking on a new build project itself, we have identified that there are 7 success factors required for successfully developing these projects. I'll do a quick tour about these 7 elements because they are all important and they all touch one way or the other into the vendor and industrial structure of a given country. Of course, one of the key elements it is the ownership structure. It has to do all with the levels of maturity of the nuclear industry in each of these countries. It can be a sovereign, corporate, or project-based model. It has all to do with the control that a country utility is comfortable in those execution experience on mega projects as well. Same and linked with the contract approach, right? Whether those are turnkey, split, and multi-package. A turnkey obviously being the most risk-averse versus a multi-package where you would be having the experience to control all those different elements of a very complex project. Obviously, the regulatory environment and the stakeholder management are 2 other important points in the delivery of these projects. And I think that the next 2 are perhaps the ones that we would underline that importance, the project management, where managing these highly complex projects requires, lots of controls, very, very, very disciplined project manage and risk management, quality assurance and planning are at the top of it, not only from the management of the project as a whole, but the different subsets of this. Then, as well as I highlighted, the supply chain aspects of them, the identification of potential challenges are going to be based as well on the ratio of localization that is going to be given. There, as we will see on some of the next slides, nuclear maturity is going to play quite an important choice in the number of localized scopes we want to look, and then also the localization criteria we will discuss about the strategies to get there. Finally, workforce management, not to be negligible, especially seeing the experience on some of projects that we have been executing in Europe. Of course, that point number 6 will have a big part of the presentation today. Now, regardless of the contract approach, and we take here 2 examples and case studies from the United Arab Emirates and the Baraka reactors, or the UK at Hinkley Point. Typically, these projects rely on independent international engineering companies. Now, there are a number of very large scopes that we have very, very simplified summaries in these couple of slides. I mean, the difference between the 2 case studies is the more EPC approach versus multi-package we were describing on this slide before, but acting as an interface between the vendor and the host country engineering and construction companies, and reviewing, adapting, and ensuring the project is correctly carried out will require some of that support. And without going to all the bullet points, I will make also a highlight touching today's topic, which is the end-to-end procurement management. There's a lot of work required in the definition of work packages, RFP preparation, bid reviews, and contract award. Now, based on the nuclear maturity, some of the host countries can find it challenging to cope to different levels of localization. As in some of the presentations before, we also saw some of the choices in the presentation from TÜV that we saw earlier on. This is perhaps a bit of a different way of portraying those choices on localization. But we describe them in our methodology between deep, medium, and shallow localization. We have put there a number of examples on this graph where we correlate the nuclear maturity with the localization percentage and types of the scope that can be given to a given country on a given project, or a first-of-a-kind reactor that can happen as well in a country that has nuclear experience. Let me give a quick example, perhaps with the reactors in Sanmen in China, where China was taking a foreign technology and adapting it to the countries, right? When you start in the middle of the screen with the first two units, the level of localization obviously is lower because at that time also the Chinese industry had less experience working with this particular technology, while a decade after, Sanmen 3 and 4, a bit less than a decade after, the percentage of localization could be considerably higher because of the supply chain adapting and knowing, both the regulatory and also the key important points for managing that localization. So if we go into each of these three areas, obviously there are a number of requirements that the host country and that the host supply chain as a whole need in order to be able to go for one scenario or the other. There are a number of requirements that for the host country, and there are others that are more specific to the supply chain. If we would go to a deep localization, there should be a nuclear industry know-how in a given country and previous experience in the construction and operation of NPPs. Also heavy forging capabilities. Why are we referring this? That deep localization would mean that the country is able to produce some of the key elements of the NSS equipment, thinking of the steam generators, of the reactor head, etc. That's important. I'm mentioning on forging there. Now, supply chain management challenges would be the transfer, knowledge process, qualification, monitoring, and quality assurance that are probably applicable for all items, but in particular for deep and medium. In terms of medium, that is more realistic in cases like Poland. There should be previous experience provided electrical and mechanical equipment for conventional combined cycle and cogeneration plants, right? Meaning experience in building power plants and constructing them in the countries. There, obviously, the challenges is the identification and capabilities of auditing to bring them to the nuclear side. And then we have to bridge as well, more than the lack of awareness, in some of the lack of experience, perhaps on some nuclear codes as standards. Some of the presentations that we have seen before have touched on that point. Finally, a shallow localization. I will not dwell on this one because I do not think it will be the case that we are talking here. Would be more for countries where that experience in building conventional plants doesn't exist, or the industrial bases are less, and then construction would be the key area of that localization. So once that we have that introduction, if we go to the next point, a word on conventional versus new build, and some points noteworthy, for vendors getting into the more nuclear world. I think in terms of vendors getting into the nuclear industry, I think there are a couple of elements that are quite important here, and our requirements, quality, and safety culture are probably some of the biggest differentiators and some of the biggest challenges as well that we're going to be facing once that we're producing goods or services for the nuclear industry. It is crucial for potential suppliers to have a positive nuclear safety culture developed and demonstrated by all organizations and individuals. It is important for companies to understand the key difference working in nuclear compared to conventional activities during the commercial actions bidding process and project delivery states. Now, a quality assurance program, and of course this has been mentioned before, designed and implemented by trained personnel, shall be in place in each supply chain organization in order to develop the processes. All managers and personnel in supply chain companies shall understand how their work contributes to the delivery of the power plants. and all parties shall understand the processes of inspections, tests, analysis, and acceptance criteria. I think, of course, this exists in conventional areas as well, but the level of inspections, analysis, documentation that is followed in the nuclear supply chain is considerably higher. Of course, there are some elements that we would always take into account in a conventional versus a nuclear plant. If we take from the perspective cost, time, and risk, in terms of cost, I think there are always a number of elements that are going to be considerably higher in the nuclear side. Number one, the documentation required to prove of concept of any good is much higher. There are seismic tests, there are plenty of tests that need to be proven and documented that we would not do for a conventional part. The time that takes, of course, it is reflected in the lead times that are required to produce nuclear goods. And in terms of risks as well, that ends up being reflected in the overall cost because we need to take everything into consideration. In terms of the quality and safety culture, there are three key elements that are going to need to be taken into consideration by companies that are developing this quality and nuclear expertise. And those are management systems, management commitment to safety, and individual commitment to safety. Each of these elements, that they come from the policy level commitment to the manager's commitment, to then the flow down to the individual's commitment is critical when we are developing those programs and training the personnel. Now, if we are to take some key differences between conventional and nuclear projects. I've mentioned safety and quality, but there are two other elements that are extremely important here, which is the licensing. I've seen a presentation that was referring to this earlier on, so that hopefully was covered there. And then those project management activities. Those project management activities, they do not refer only to the construction of the plant itself. It has to do as well about the project management for those suppliers producing goods and services, and the understanding of all the critical milestones that are needed to produce those. And that goes very accurately to the audits, to the hold points in the process of manufacturing nuclear goods, to other areas, extremely important to take into consideration. Now, if we review how to implement that nuclear integrated management system, we've been touching some of these points before. This pyramid kind of reflects this, which is the safety culture, the safety management system, and the quality levels that are required to do so. I think what is important in this point is to understand as well that in order to build a system of this nature, a control of the supply chain is extremely important. Certifications of personnel are very important. Understanding which suppliers we've qualified to deliver the services are very important. The raw material certifications we're using are very important. Raw materials will also be dependent on the code and regulations we're going to be following. It's not the same to use certain raw materials in an RCCM code that an ASME on some occasions. So their equivalence table, et cetera, et cetera. So all of those elements are extremely important in order to be able to be a nuclear supplier. Now, some typical issues and lessons learned from some new build projects, really summarizing to some bullet points. This could take hours of literature. But I think if we go first on the finding columns that we have here on the left, the escalation and increased requirements by the safety authorities, especially post-Fukushima, is something to take into consideration. Of course, 2011 may seem very far away, but that has been certainly, even for the experienced nuclear vendors, something that has added in terms of documentation, in terms of requirements to be demonstrated. A lot of suppliers have experienced quality issues in early production and fabrication. I will say this, especially in some of the Western countries that rebuilt some reactors. Some of examples I can think of in the Americas, in France, or in Finland, for example. There was a lot of that due to the loss of nuclear know-how. This may be less, for example, in the case of South Korea, that continued nuclear construction across many years, and they have not seen that loss of nuclear know-how, but that was definitely the case. Some of the advantages, for countries like Poland is that a lot of that nuclear know-how has been regained, at least partially, in a lot of the supply base. Audit and surveillance that failed to uncover significant issues. A conventional audit approach has some gaps compared to that nuclear one, and there was some lessons learned in that area. And also, the licensee had to take much more intrusive role in supplier oversight than expected. I think this has been in both cases in those Western countries that I mentioned before. In terms of lessons learned, vendors must have a strong nuclear safety culture that starts at the top. Licensees must ensure standards and expectations are starting with vendor executives. Extremely important. This may sound very common sense, but that is definitely the case. The vendors QA, the quality assurance and quality control organizations must have nuclear expertise. It's strongly suggested for some of you that will not venture into that to get support from people that have that nuclear expertise and understanding of the regulatory requirements of whatever technology will be decided as the technology to be used in the Polish reactor. Let that be American, Korean, French, whatever OEM. Accurate flow down of design and licensing basis requirements to the whole supply chain. This is, from the tier 1 to the tier 2 to the tier 3 suppliers. There is a tendency not to flow down all those requirements across the line. And then, of course, finally, change management processes that need to be verified. Last but not least, in the last remaining 5 minutes of the presentation, I think what's important to go into the understanding on how a localization strategy is defined for both the vendors to understand how that is, and also in terms, more from a government and utility perspective to see what choices are in terms of the ratios. Because at the end of the day, a lot of this is a dialogue between the definition of what the localization strategy of the country is and what the supply chain locally can do. If we would look at a typical process of developing the nuclear value chain of a first of a kind project, we would start with a demand quantification, like with many of the projects, looking at value chains. No, we look for the construction of a nuclear power plant. Then we need to understand what main packages are we really looking for a localization strategy. And then we should choose a methodology for calculating that localization ratio. Then you would need to evaluate, assess the situation of the supply chain, be realistic on what can be done and not done, and then develop that business plan. And of course, marketing plan to attract investors. And finally, you have to create an organization that is going to be responsible to implement this. I mean, this is not going to happen on its own, right? A benchmark analysis of the best practices for localization activities, it is something of highly convenient. Let's take an example, right, of what we really mean. That it can be a bit abstract, but if we would, for example, assess, all the capex that goes into a new build project, you start breaking down this in work packages, right? And then you can take, for example, figurative numbers that are not far from a reality. If the capex of a reactor is on the 5.5 million USD, 5,500, sorry, million USD, and then you start breaking that between the components and in the middle, the construction and erection, and then you look into the different contract categories. You will have the electrical IMC installation, the enabling works, the mechanical equipment, the civil works. Then the civil works, you start dividing those into different work packages and start defining some of those activities. And then you're going to classify into a potential localization, yes versus no. You can also take that same package and go for a first of a kind versus the subsequent reactors in terms of localization ratio, because of course, as in the example of salmon that I gave on slide number 5 of the presentation, you can start defining for the first of a kind a 30% localization ratio that can become a 60% for the subsequent reactors. Now the suppliers have gained experience in that. So that strategy needs to be taken into consideration. For that, of course, you will need to identify those sources, the vendors as well. If you are a valve or a piping or steel structure manufacturing in Poland and you're listening to this, that is something as well that would be also interesting to have the dialogue, with the different companies that are going to have that structure to make that proposal, right? But with all that identification in terms of the strategy, there will be a definition of what can be done in the country. Now, there are, of course, certain categories that have a higher localization potential than others, right? If we look more into the construction and look at some of the detailed engineering, if we look at some of the components as piping, some valves, some pumps that are non-nuclear safety, that has a higher localization percentage than, for example, some of the core design or the forging components we were mentioning that could go into the NTRIPOLE supply. Obviously, the turbines as well, nuclear class turbines are a bit more complicated to go into those. But there are, of course, categories that lend themselves easier. And if you are in these areas, of course, that categorization will be easier. And to finalize, of course, then the prioritization ratios, would be taken into consideration through the attractiveness, ease of implementation, and fit on an overall strategy. So with that, closing slide, bottom line, the dialogue between the 3 key elements of the nuclear ecosystem is going to be extremely important in order to understand, what opportunities lie there in terms of the Polish supply base. The national government and agency, of course, will be determining those ratios, that strategy of localization. The owners and operators will have to contractualize some of the packages that are going to be defining and flowing down those requirements of localization into the different RFQ packages. And then the local supply chain will be there to deliver and hopefully to develop an expertise that can be exported abroad, as we have seen on some cases of countries that have localized successfully, and notably, I think South Korea, China, India are examples of that, but closer in Europe, I think we had Matteo mentioning the case of Spain, or Finland, Sweden, other countries that adopted nuclear strategies as well, far away in the time. And with that, I think that closes my presentation. So thank you very much all for your attention.
Thank you very much for very interesting presentation, especially in light of the subject of today's web seminar. Localization issue is one of the key elements of the program, a nuclear program in Poland. And obviously there are many questions to your presentation, but due to limited time, I ask you one or maybe two. The first one is, to what extent localization ratio is linked and dependent on a selection of a technology supplier?
Well, I mean, that's a very good question. And indeed, it very much depends on how vertical the supply bases of that technology are. I think today most OEMs that you are considering, and if we consider it public, this is no secret. You are considering, the American AP1000, the French EPRs, the Koreans notably don't want to reduce it, but just to give those three examples. I will not name which ones, but some of them have a more vertical supply chain than others, you see. So I think it will have an effect. I think if I classify those three ones without saying which one is more than that, I don't want to get into the polemics here, but I think one will have more potential for localization, will have much less, and another one will be more in the medium. Two of them will be trying to have a similar localization, because I'm sure that Poland, being an industrialized country, will want as much of that localization to happen as obviously any country would want to if investing in there, right? But there will be an impact. I think notably of those three countries, there is a much more vertical part of the supply base because of the delivery of a lot of plants in not so far future.
And the second question is also, I think, political and difficult to answer, but I need to ask you. You mentioned about these three localization ratios and between deep, medium, and shallow. And as you probably well know, Poland aims at probably medium. In terms of its potential experience, especially in construction of conventional power plants. But in terms of ratios, specific ratios, what are the ranges between, let's say, what are the numbers behind these three types of, let's say, of ratios?
Well, you see here, you can play some tricks. I will not try to. But the thing is that it depends if you compare the number of components of the number of money. You see, it's very easy.
Total value of project.
Total value of projects. In total value of projects, I think you can go, because of the high value of construction, you can localize rather up to a 40%. You would go between the shallow and medium, right? The medium would be more between the 40 and 70%, and the deep would be above that 70%. Now, that medium, of course, to get from a 55 to a 70% is probably the most difficult part of all that, because that's where you have a lot of the medium to high safety components that are not necessarily core to the reactor.
Okay, thank you very much. There is no time for further questions, so thanks again.